Okay, so now part 2, chapter 1, chapter 2. So how matter changes? So matter changes in physical changes or chemical changes? Changes. And physical changes occur when the form or the appearance of the matter changes, but the substance is still the same. For example, here, I have H2O, right? Is as a ice in the solid, as liquid here as water, and a gas as a vapor. Different physical conditions, right? But the same compound, the same H2O. So the physical change, the physical appearance of a substance can also change with a physical change. All right, talking about physical changes. And about here you have chemical changes. Chemical changes occur when a substance is turned into another substance. So for example, here you have a compound element A reacting with B, you make completely different thing. Here, another compound. Have reactants make a product, right? In a reaction, for ordinary reactions, you need to consider the law of conservation of mass. That says that mass is neither created nor destroyed in a chemical reaction. For example, here, we have 2 grams of reactant A, a reactant with reactant B, 1 gram of reactant B, so mean in reactants, you have a total 2 plus 1, 3 grams of reactant, right? That means your product should be also the same amount. So your products here should be, for example, 3 grams. So the mass was not created or not destroyed. I mean, was not more or less. Should be the same amount, right? All right, so have you some the practice problem here. Classify each of the following changes as physical or chemical. So burning can, you are burning, you are changing the substance there, right? So it is a physical or chemical change here. So here should be a chemical. When you are burning, you are making a reaction. In icing, icing, melting on the street here. So ice, the solid H2O to the water H2O, but still H2O, right? So to be physical, because it's not changed, it's still H2O. So toast and marshmallow. So you are also burning here, so you are also making a reaction, chemical reaction, the chemical change, and cutting a pizza. So you can count different shapes, right? But still be a pizza, so it'll be physical changes. In iron rusting in an old car. So you are seeing a change in color, right? So you are seeing a reaction happening here. So we have here a chemical changes, right? Okay. So talking about observations, right? You're observing colors changing, you're observing the physical state changes. So here, the next topic is about units, measurements, significant figures, dimensional analysis and dimensional analysis. Previously, we talked about making observations and obtaining qualitative information. In chemistry, also obtain quantitative data. So before we talk about observation, right, there's qualitative data. Now we're going to be calculating measurement to get quantitative data. And so we'll be making measurements of length, volume, mass, and temperature. So a measured value has three components: numerical quantity, the unit, and the name of the substance. For example, here, 256 grams of lead. So have we the number, the units, that's grams, and the substance, right? So we need to interpret here in what we'll have here, the information. Right. To talk about quantitative data, we need to learn about units of measurements. So, SI units, the system of units used by chemists in the International System of Units, SI units, which is an updated form of metric system. So you have metric, for example, measurement for volume. In the metric is liter, and the SI is cubic meter. The length in metric system is meter, and SI is also meter, right? You have it here. Mass is metric is in grams, and SI kilogram. Temperature is in degrees Celsius for metric, and SI will be Kelvin. And the time will be both in seconds. All right, okay, volume. Volume is the space occupied by a substance, right? And commonly used measured in liters and milliliters. In each 1 liter, you have 1,000 milliliters, right? And about length. What's length? Length is a measure in units of meter in both metric and SI system, and in centimeters by chemists. The relationship here between the units of length, you have, for example, we have 1 meter. Into 1 meter, you have 100 centimeters, right? And 1 inch is equal to 2.54 centimeters. Okay. Next is mass. Mass of an object is the measure of quantity of material it contains. To be measured and using an electronic balance, and the SI unit for mass is kilogram. And it's often measured by chemists in grams. So the relationship for mass is you have 1 kilogram is equal to 1,000 grams. So, and each 1 kilogram, you have 2.2 pounds. The next is temperature. Temperature is a measure of how hot or how cold the object feels. And you have different scales here. Kelvin, right? This one in Celsius scales, and then Fahrenheit scale, right? So in Celsius scales, the water freezes at 0 degrees Celsius, right? And in Kelvin, in 273 Kelvin, and in Fahrenheit, 32 degrees Fahrenheit. This is the water freezes. Okay, so we have 3 scales, right? For temperature. And how do this conversion here? To convert it from Celsius to Kelvin, we're going to get the temperature in Celsius, and ADAPT plus 273.15. Some books it's okay, you could do only 273 too, right? Converting from Celsius to Kelvin, just adapt. Like for example, to have 5 degrees Celsius to Kelvin will be 25 plus 273 will be 298 Kelvin. Okay? And the time the measure will be in seconds. Okay. Measure numbers. Measure numbers is the number that depend on how they were determined. Scientific instruments have limitations, and individuals can read some instrumentation differently. For example, here, right? This object here has this length here, and is between 4 and 5. So you can estimate here that this length is 4.5, right? Because the ruler here is reported only every 1 centimeter. So the estimated number is the final digit that is reported for a measured number. Here you are measuring. The here have between 4 and 5, so you are estimate, okay, it's 0.5, 4.5, right? Now, if you have the same object here, but a ruler that you can measure is marked every 0.1 centimeter, you can have a better estimation here. So you know that it's 4.5, right? And it's between 0.5 and 0.6 here. So you can have a better estimation here. That is 4.55 centimeters. So you can now estimate that the length is halfway between 4.5 centimeters and 4.6 centimeters mark, and report the value of 4.55 centimeters. Correct. So the next is accuracy and precision. What's the difference between accuracy and precision? Precision is a measure of how closely individual measurements agree with one another, right? And accuracy refers to how closely individual measurements agree with the correct value or true value. So for example, the first one here, you have all the trials here in the center, right? Went here to the center, the target. That's the true value. And that it means you have a good accuracy that all trials here, they got here the true value. And good precision because all the 3 trials here, they are very close to one another, right? Here. So good precision, good accuracy. The second one, you can see they are not close, they are not around the center, right? So that means that it's not a good accuracy. But even all 3 trials, they are very close to one another. So that means it's good precision. The trials got about the same number. Like, we're not right, but still got about the same number. And the third one is a nightmare of every scientist who do not want this. Because here, bad precision, right? And bad accuracy. Like all the experiments here, they are not closer to one another, and they are not in the target area, right? So bad precision, bad accuracy. Okay. So you have here, which piece of glassware should you use it when measuring volume? We have here graduate cylinder, syringe, and burette. So these 3 glassware, they have different marks to measure different volumes. And the pipette and volumetric flask, they have just one mark. So it's used to measure a specific volume. Right. Talk about numbers, about precision and accuracy. You need to understand about significant figures rules here. So all digits as a measure, all digits of a measured quantity, include the uncertain numbers, as uncertain ones are called significant figures. So when rounding calculated numbers, we need to pay attention to significant figures so we do not overstate the accuracy of our answers. The first one, all non-zero digits are significant. So you are going to consider all non-zeros. The main rule is the rules are about when we have zeros, when zero will be significant, when zero will not be significant, right? For example, here, the number 2. Zeros between non-zero digits are significant. For example, here, if you have 302, how many significant figures you have here? 1, 2, 3. Because this zero here, this zero is between non-zeros. Then number 3 here. All zeros to the left of the first non-zero, they are not significant, like here. All zeros to the left of the first non-zero are not significant here. So how many significant figures you have here? Talk about non-zeros to the left. So all the 3 zeros here, they are not significant. That means this number here has 3 significant figures. The zero after decimal place, yes, you count. Then number 4 here. All zeros after decimal point are significant, like I showed you here, right? For example, how many significant figures you have here? 1, 2, 3, correct? All zeros after the decimal point are significant, so 3 significant figures. Then the zeros at the end of a number are significant if it contains a decimal point. Right. So for example here, how many significant figures you have here? Zeros at the end of a number are significant if it contains decimal point. So here you have all decimal points, right? So that means in that case here, you have how many significant figures here? 1, 2, 3, 4 significant figures here. Right? But if the number does not have decimal point, like it was like this, 100, without any decimal point, how many significant figures you have here? Only 1. So here is all because we have a decimal point, but you do not have. So the 0 here, they are not significant in that case here. Right? So for example here, 500 grams. You have 500 and you have a decimal point here, so you have 3 significant figures. And this 400,000 meters, there is no decimal point here, so just 1 significant figures. In the last 1.30 centimeters, you have the 0 is after decimal point, right here. So you counted only 3 and 0 as significant figures. So in that case, here you have 2 significant figures. And you also need to practice how to write the number in scientific notation. So 500, we have 5 here. Then 2 zeros, so 500, you can do like 5.00 times 10 to the second grams. It's still gonna be 500. It's still gonna be 3 significant figures here. All right. And about this one here, how many significant figures are in the number 0.00108 here? So all the 3 zeros to the left, right? They are not significant, so they do not count. You're going to count this 3 here. 3 significant figures. You have 1 zero between non-zeros numbers. Okay, so we'll now talk about when the numbers are significant and when they are not. And you also need to learn about rules for significant figures and calculations. So the least certain measurements limits the number of significant figures in the answer. When you have addition or subtraction, the answers are rounded to the least significant decimal place. When you have multiplication or division, the answers are rounded to the same number of digits as the measurements with the fewest number of significant figures. All right, okay. And rules for round off numbers depends about the 5, right? If the digit you want to drop is less than 5, drop the digit and any to the right that the digit. So for example here, if I have the number 8.4, 8.4234, and you need to round to 3 significant figures, you are going to drop these 2 here, right? 3 is less than 5, so you are going to round to 8.42 only, right? Now, when the digit you drop is 5 or greater, increase the value of the last digit retained by 1. For example here, the 14,780, right? And I'm gonna round to 3 significant figures. So we are going to drop 80 here. And because 8 here, right, is higher than 5, so the number gonna be, the 3 significant figures will be 14.8. So we're gonna drop the 80 and increase the last retained digit by 1. Right? Say, okay, now let's understand about when. So when you have a multiplication and division. Multiplication or division, the results carries the same number of significant digits as the factor with the fewest significant digits. For example here, there's 3 numbers here, right? We have multiplication and division here. This one has only 2 significant figures. This one has 4, and this one has 3. That means your answer should have the least one. Which one has the least number? Significant figures is a 2.28 that has only 2, correct? That means your final answer should have only 2 significant figures. So you are going to round all this number here. Your calculator will show this number, right? I'm going to drop everything here. It will be 5.4. It is 5.4 because it was dropped here, start on 2, and 2 is below less than 5, right? So it's rounded to 5.4. when the calculator answer is small whole number, the more significant figures are needed, you just added one or more zeros. For example, here, you have this division, right? 8.00 divided by 2.00. So your final answer should have three significant figures. But when do this division, your calculator will display only 4, like this. But you should have three significant figures, so you're gonna add the 0.00 to have three significant figures. Your final answer. Okay? And then when you have addition and subtraction, so we're going to count the least decimal place. So in addition or subtraction, the results carries the same number of decimal place or the quantity carrying the fewest decimal places. For example, here, if we're going to do this addition here, right? You have 2.012, so 3 decimal places, plus 61.09, so 2 decimal places, plus 3.0, so 1 decimal place. Your final answer should have which one is the least number of decimal place. So having 3, 2, 1. So your final answer should have only one decimal place here. So when you do this addition in your calculator, you're going to show this number, 66.102. So, but you are going to add, your final answer should be only 66.1 to have only one decimal place. Exact numbers. Those numbers are obtained by counting the exact numbers. For example, 3 grapes, 3 bananas, 3 fruits. Definition that compare 2 units in the same measurement system. For example, 12 inches is equal to 1 foot. They are also exact numbers. So exact numbers, they are not measures. So they don't have a limited number of significant figures and do not affect the number of significant figures in our calculation. Exact numbers, the integral numbers, that they are part of the equation. Constant values, they are not also significant. The constants, the measured. So for example, here, some examples of some exact numbers. So for example, 5 capsules. Okay, you can count 5, right? So exact numbers. In the equalities here, the units, like every 1 liter is equal 1,000 milliliters. So they're also exact number. Yeah, so don't counting the significant figures. So don't look for these numbers to find the correct and significant figures on your answer. They're only, so that even here, we're going to use the conversions factors, right? So do not worry about significant figures for the exact numbers. Only the measured number. They're going to be using significant figures. Okay, we talked about significant figures rules, right? You need to make sure that we are reporting the units. The units in the metric system here. So the kilo means 1 meter, 1,000. For example, 1 kilometer, you have 1,000 meters, right? Here. 1 kiloliter, 1,000 liters. 1 kilogram, have 1,000 grams. So the kilo means 1,000. So have here some prefixes that, for example, nano is 10 to the minus 9. kilo means 1,000. All right, so you have here metric length equalities. An equality shows a relationship between two units that measure the same quantity. For example, in 1 meter is equal to 100 centimeter. In here, medical measurements in conversion. The volume of 1 liter or smaller are common in the health sciences. When a liter is divided into 10 equal portions, each portion is called 1 deciliter, right? So the cubic centimeter is the volume of a cube with the dimensions 1 centimeters times 1 centimeters times 1 centimeters. And each 1 cubic centimeter is equal to 1 milliliter here. So a cubic centimeter has the same volume as a milliliter, and the units are often used interchangeably, right? Interchangeable. All right, so here I talk about the basic as a unit of mass is the kilogram. There are 1,000 grams per every 1 kilogram, which 1 kilogram is equal 1,000 grams. That's in scientific connotation is 1 times 10 to the third grams. Right. Okay. Dimensional analysis and conversion factors here. In chemistry, when you are dealing with specific quantities of chemicals, it's often necessary to convert from one set of units to another one. So we need to do dimensional analysis. So the most widely used approach to solving this problem is called dimensional analysis or factor label method. We're doing the conversion using dimensional analysis. For example, like with 1 inch, you have 12 inches in 1 foot, or the division between like 1 foot is equal to 12 is the relation between 12 inches. It's 1 here. 12 inches in 1 foot is equal to 1 because they are the same, right? The same, like they are equivalent, equality. An equality shows the relationship between two units that measure the same quantity. An equation factor is the ratio of two equivalent quantities using different units. How are you gonna solve your problems, the questions like this? The first one, you're gonna write the given unit, and then do the ratio here between desired unit on the top and the given unit on the bottom. So this portion here is your conversion factor, right? When you're gonna cancel, so given unit times desired unit divided by given unit is equal to, so we're gonna cancel given unit with given unit. So the left that you have here is your desired unit. So the problem solving process begins by analyzing the problem in order to identify the given units. So first need, okay, what was given, right? Then you write a plan that converts the given unit to the needed unit. So here this was given first, and then you want to convert it to the desired unit. And then set up your calculation. Use the form of the conversion factors that it puts the unit you want in the numerator. So what you want should be in the numerator here, and the given unit should be on the bottom here, should be in the denominator, so you can cancel out, right? So this problem here. If your friend's foot is 13.5 inches long, how many feet is that actual to what? To how long it is? How many feet will you have at 13.5 inches? So first, what we have here, right? You know, let's do the quantities first. The given, what was given? 13.5, oh, sorry, here, inches, right? It was given. And they need to convert inches to what? To feet, right? So we're gonna do this here. So the plan, the given unit to the needed unit. So we're going to write this. So the given unit, right? I'm just repeat what's here for now. Unit, the given unit, desired. So we're gonna cancel given with given. So we have here the ending, right? The desired unit. Okay, what was given? What was the given unit? Was 13.5 inches, right? So you know they're gonna be something like this, right? 13.5 inches was the given, right? And the given unit repeated here in the bottom. So what you know here? The foot, which one are gonna be on the bottom? The inches or the feet here? So the given unit will be in the bottom right here. So inches. And the desired unit gonna be on the top. It's gonna be what? Like feet here. But what is the equality here? The equality and conversion factors. So what you know here? And at 1 foot, 1 foot is equal to 12 inches, right? Here. We have 1 foot, 1 foot is equal to 12 inches. So we're going to do the conversion here. So you know that 1 is equal to 12 inches. Now let's do the calculations here. Set up the problem to cancel out units and calculate the answer. So initial 13.5, right? Inches here times. You know that here, right? It should be 1 foot first. 1 foot is equal to 12 inches. I'm going to cancel here inches with inch. Be equal to what then? 13.5 times 1 divided by 12, right? So I'm going to do a division here. And then I'm going to write the gonna be what here? So we do the division 13.5 divided by 12. What we have here? 1.125. When it cancel the unit, right? Inches cancel with each inch. So we have here gonna be foot. But now, what else we need here? How many significant digits should we have here? Let's go to the question. The question gives this number, 13.5, just one number. This number here has three significant figures, so you should round your answer to three significant figures. So should be what? 1.1 what? 205. Sorry, 203, 1.12 or 1.13. So we are going to drop the 5. When you are going to drop the 5, the number here will be added by 1. It's going to be 1.13 foot, right? Have some problems here, so guys can practice. Okay. So now it's about density here, right? Density. So quantities that are measured and calculated here. Basic units that are measured in size, for example, you measure milliliter, you measure liter, you measure grams, right? And for example, how density, you want to calculate density. Like density will be, for example, grams per milliliter. I'm going to take the mass given divided by the volume, for example, to calculate the density. Talking about the density, the density is the relation between mass of a substance by volume. So density compares the mass of an object to its volume. Is the mass is the division between mass and volume. So for example, we have here this beaker with different object here, right? The one that has higher density will be on the bottom. The one of lower density will be on the top here. The water, right, has a density around, for example, 1 grams per milliliter. And you have here in this beaker have water, right? The objects here that they have lower density than water, they are floating. For example, the cork, the ice, the water here is 1, and the lead here is on the bottom because it has higher density than water. In the case here, 11.13 grams per milliliter. So the denser, the objects, they are denser than water. They sink. The one that it has less, they are less density than water, has lower density than water, they will be floating here. Right? Okay. So determine density using volume of displacement. For example, here, right? You have in this graduated cylinder, you have a volume like here, 45 milliliters of this liquid here, 45.0 milliliters. And then you are gonna add this solid here, like this zinc. The zinc has a mass initially 68.60 grams, 68.60 grams of the mass of the zinc. And what's the volume? Let's measure the volume. How can I measure the volume here? I'm going to add this zinc inside this graduated cylinder with this solution. And let's measure what will be the difference here. So initially, the volume was 35.5, right? And when we added the graduated cylinder, when we added the aluminum, change it to 45.0 liters. So actually, This was the initial, sorry, the initial was actually 35.5, right? Initial volume. And the final was 45.0. So to find the volume of zinc, we're going to do a subtraction of the final volume minus the initial here. And to find the density, we're going to divide the mass of the zinc, 68.60, divided by the volume, the difference here, 45.0 minus 35.5. So we're going to divide 68.60 divided by 90.5 milliliters. So this one has 4 significant figures. This one has only 2. That means your answer should have 2 significant figures because we're counting the least one, right? So your answer should be 7.2 grams per milliliter. So you needed to have a scientific calculator, right? And um problem calculator, non-graphing for your exams. It needs to be a scientific one. To learn to use use a scientific calculator and scientific notation. So you can enter number, written, and scientific notation on many calculators using the EE or EXP key. Right? You make sure you get practice and use your calculator, right? And let's stop here, chapter 1.